Hello there. In previous lessons, we discussed the various building blocks that go into constructing a convolutional neural network and learned how to train such a network to perform classification. With the growing popularity and indeed performance of deep learning classifiers, an obvious idea is to replace hog-based classifiers with a more accurate CNN-based classifier in object detection problems. However, there is one slight problem. CNNs are slow because computationally they are very expensive. It is simply infeasible to run CNN classifiers for every possible search window in a sliding window detector run on an image pyramid. In this lesson, we are going to examine the challenge in extending these classification networks to detection as well. That is, in addition to deciding what objects are in an image, figuring out where those objects are. When used for object detection, both HogSVM and Viola-Jones successfully use sliding windows to check various patches on an image for the presence of the object they are searching for. Viola-Jones had some tricks for accelerating the calculation of features at different scales, so it quickly scales its features rather than the image. It was able to do this because of its relatively crude features, but the downside to this is that it isn't able to classify as accurately as systems based on Hog features. HogSVM did not have such tricks, although there are some derivative algorithms that try to add similar techniques. So in general, HogSVM scales the image and conceptually forms an image pyramid search space. But this entails calculating Hog features at multiple positions and across multiple scales. More significantly, it involves running the support vector machine classifier against Hog descriptors built from all these possible feature positions. These activities add up to significant costs in computation. CNNs, of course, are multiple layers deep and consist of millions of weights, compared to less than 4,000 for our HogSVM pedestrian detector, for example. Therefore, the image pyramid approach was just not practical for CNNs. It was never going to work. So instead of exhaustively searching an image for objects in all possible locations, what if we could quickly generate a set of proposals as to where objects might be in the image? We might use basic image features and visual cues, such as textures, intensity, colors, edges. We could then resize these patches into an appropriate size for our CNN classifier and run it against them. We are going to look at a set of algorithms called object proposals that can do just this. Object proposals are typically computationally cheap and fast in execution time. Their purpose is to efficiently prune the image pyramid search space for us, picking out likely candidate positions for objects and quickly rejecting the rest. Some object proposals are based on growing superpixels, a concept we reviewed earlier in the course. Others are themselves based on sliding windows, but typically with fewer windows and with much lower cost operations performed at the window positions. A first step to building CNN object detectors was to pre-filter the image with object proposals and pass the set of possible object positions into CNN classifiers to make the decision. The aim of our detector is to output a set of classification scores, as well as outputting a set of bounding box coordinates. So maybe top left X, top left Y, bounding box width, and bounding box height. Again, it would be terrific if our detector could take this patch input and output refined bounding box positions, as well as the score. We'll see that deep networks can also learn to do this. Beyond this, we'll also learn how deep networks have evolved, in some cases, to learn their own object proposal functions, similar in concept to the way deep networks learned their own feature extractors. This is the same added benefit that the object proposal function within the deep network can be jointly optimized with its subsequent feature extractor and classifier through back propagation. Finally, we will also look at an entirely different set of CNN detectors that don't use object proposals, but instead treat the problem as a regression problem. That is, one of predicting numbers for our score and bounding box positions.